Let us see what a linear regression model says and how we can use the model for prediction. We will use scikit-learn's linear regression class for creating the model and do the prediction. We are separating the independent variable columns in a two-dimensional array X. That is, X contains the first three columns: water per acre, salinity level, and fertilizer per acre of the data. Now we are taking the dependent variable column, that is the pecan production column, in a one-dimensional array variable y. To create the model, we use the fit method of linear regression using the data in X, which are associated with the independent variables. The fit method will try to fit the model and the data with the dependent variable, which is pecan production observations, in y. The model is created. To retrieve the coefficients with the independent variables, we just print model.coefficient or coef underscore. The model.coef provides the coefficients associated with independent variables in the sequence as the columns appear. That is, the coefficient associated with water per acre is 0.81272313. The coefficient associated with salinity level is negative 3.30151539, and the coefficient associated with fertilizer per acre is 0.39332994. Remember that earlier we observed through visualization that the more the salinity level, the lesser the pecan production is. This is reflected by the negative coefficient associated with salinity level. A positive coefficient indicates that the dependent variable increases with a higher independent variable. A negative coefficient indicates that the dependent variable decreases with a higher independent variable. In this context, water per acre and fertilizer per acre are positively associated with pecan production. The salinity level has a negative relationship with pecan production. The larger the magnitude of a coefficient is, the stronger the relationship between the respective independent variable and the dependent variable is. Here, the coefficient associated with salinity level is negative 3.30151539. The magnitude is 3.30151539, which is quite larger than the coefficients associated with water per acre and fertilizer per acre. The meaning is slight increase in salinity level will sharply drop the pecan production compared to the increase in pecan production due to increase in water or fertilizer. Also, the magnitude of the coefficient with water is higher than the magnitude of the coefficient with fertilizer. That is, for an equal amount of increase in water and fertilizer, more pecan will be produced for water compared to fertilizer. That is, the coefficients give us a lot of insights. If you are using any other regular Python editor instead of the Jupyter notebook, you can put the model.coef underscore inside the print method to get the same output. The intercept can be retrieved by model.intercept underscore. For the given data, the intercept is 488.88676981, so on and so forth. The meaning of the intercept of this data is that if the farmer cannot afford any water, any fertilizer, and if the salinity level of the soil is 0, still the pecan production will be 488.88676981 units. That is, with all the independent variables being 0, the predicted pecan production will be 488.88 something. Now, consider that you have 4 clients who are pecan farm owners. The first client gives you the information that next year she can afford 120 units of water per acre. The salinity level of her land is 5 and she can afford 80 units of fertilizer per acre. She asks you what will be the pecan production next year. The second client gives you water per acre, salinity level and fertilizer per acre of amounts 50, 1 and 150. Two more clients give you these two additional sets of information. Your task is to predict what will be the pecan production of each of these clients. Since you have the model, that is, you know the intercept and the coefficients with the independent variables, you can apply the formula for each client and predict the pecan production for each of the lands. The model already has a function to predict the dependent variable for given independent variables. All we have to do is take the model variable that we created from the data and call its predict method by feeding the client data into it. For the first client, the predicted pecan production is 601.3723617. For the second client, the predicted pecan production is 585.2209, so and so forth. For the third and fourth clients, the predicted pecan productions are these values. Sadly, the third and fourth clients have quite lesser predicted pecan productions compared to the first two clients. Notice that the third and the fourth clients have higher salinity levels in the soil. We already know that the salinity level negatively impacts the pecan production. Ideally, probably you will read this data from another CSV file, but for this practice, hard coding of the client data seems sufficient. Here is the summary of the entire code. Import things, read your data, check head and tail if you want, check metadata if you want, check relationship between pairs of columns of your data. Sometimes you will find interesting things. For example, here we found that salinity level of the soil negatively impacts pecan production, while water and fertilizer have positive impacts. Make sure that linear regression from scikit-learn is ready to be used. Separate the independent variable columns from data. Separate the dependent variable column. Create a linear regression model. You can take a look at the coefficients associated with the independent variables. You can take a look at the intercept. You have your client data for which the pecan productions are not known. You can use the model's predict method to predict the dependent variable, in this example to predict the pecan production. Here, I did not tell you how to evaluate the method. That means how good or bad your model is performing. If you know what is the actual pecan production for these four clients, you can compare the predicted pecan production with the actual known pecan production. There is a score method with the model just for that. I will leave it to you as an exercise. I'll provide a link to the code and the pecan data I used to create this model in a link in the description section. Prediction using linear regression is pretty amazing, isn't it?